All right, everyone, how we doing? Doing good. We're at the end of the semester, so I want to talk about what's his name? What do they call it? The next assignment I'm doing. Bless you, and bless you again. Let me see. Actually, let me just pull this up right here. Where's my? Here it is. Yeah, I'll pull this guy up too. Yeah, pull this guy right here. Wait, what the heck? Wrong one. There you go. Double click. So I'm gonna be using this bigger book that I have. I was gonna show my in-person one, but I'm like, it's okay. So this is the final assignment that I'm creating right now, and it's multi-channel circuits. Okay. I wanted to publish this, but I was like working at 2 in the morning. I was like, yeah, I should probably sleep because I don't want to feel tired. I have lots of things going on today. It's project week. Okay. But this one is a great assignment. I think I really liked it. I was going over it. Use the bus wire to create multi-channel circuits, right? And then I still need to update this. Watch how I update things. See, I'm still working on it. And then let me just update this. Let me give you a hint of what I've been doing. There you go. NAND gate schematics. So we're gonna build a NAND gate, right? You guys know these little guys, the 7400s. You guys play with them? CP 100, 200, or I don't know, some project. And you've seen this, right? And you're like, whoa, this is great. So the quad just means 4 channel, right? So there's 4 individual circuits on that chip. So channel 1, 2, 3, 4, right? Actually, you see here 1A, 1B, 1Y, channel 1, channel 2, channel 3, channel 4, right? So this lab is to more like open your eyes on like why IC design is really cool, like why it's very important, and why little simple things like you can build chips like this and be like send it out to a company and they'll use your part. Well, this do people use dips in circuits? Well, when you're building breadboards, yeah, these are great, but in reality, we use SMDs, like really tiny chips. So these are like really tiny, and they can still fit this. Of course, we're working with the 45 nanometer process, so yeah, things are gonna be really tiny. So I'll show you, and I show you the schematic. Has Ming talk about NAND gates in 421 to those who took it?
421,
Yeah, he showed you how to build it.
yeah.
Did he? Or did he just show you the schematic and said move on?
More so the schematic and like how it works.
But they didn't build it for you.
Not in my cadence or anything.
Yeah, it should have been in lab. You would have built this. You would have been masters. But anyways, this is a very simple topology, okay? And you guys understand how the NAND gate works, right? If I, what's his name? This might be a great lesson, okay? I told myself I didn't need the doc cam. Let's pull this puppy out. See, one time I said I may not need it, and then I didn't use it, and that was fine. I had it set up, but then another time now. Let me show you NAND gates, okay? Because I think for a lot of you, I think this might be your first time watching this, and I don't want to be the point. I did this thing with my 360 students yesterday. I was the point professor, point and click professor. So I used the Shams outline book. You guys know what that is? Yeah, and so I was like point, and I was like, I don't like this. Professors do this? Oh God, it felt very interesting. But we were running out of time yesterday, so anyways, let me just pick 2 colors and then visualizer. Boom. EE 420 lab. What's it called? Today is April 16th, 2026. So NAND gates, they're pretty simple. Let me see. Boom, boom, boom. Yeah, there we go. And then this is how I draw my NAND gates. Pretty simple. And it's like the heart of a lot of things. You guys seen a NAND memory? You have NAND memory by Samsung or Western Digital, stuff like this. And you'll see, if you take our 721 course, memory design, you'll understand this a lot more. Or just look at the previous courses that we've had here on cmosedu.com. You'll see some things, okay? It's pretty fun, all right? Circle, don't forget the circles. A, B, A, B. All right, so NAND gates, right? It consists of 2 PMOS circuits right here and 2 NMOS circuits, okay? In reality, digital circuits, digital logic, only relies on GND and VDD. Okay, those are the only 2 numbers. So if you're thinking like 0 volts and 1 volt, right? Pretty simple, not too hard. So it's just ones and zeros, okay? So, or 5 volts or 0 volts and 5 volts, right? And this would be your low, high, right? Not too hard. Or 0 and 1. Everyone understanding digital logic, that's intro to CP100 or something like that, okay? So let me ask you this. If I put a 1 right here, full voltage, I just take this gate of the NMOS. What happens to the NMOS? I just pull it up all the way to 1,000 volts. It shorts. Great. Okay. So digital logic's really fun. Just relax, okay? Unless you're going analog, but don't worry. Same thing with this device right here, right? If I pull this up to like 1,000 volts, well, first off, it will pop, but it'll turn on, right? So if I wanted to create a short from here to here, right, I would have to turn this one on and this one on, right? Does that make sense with everybody? And if this if this is a 1 and there's a 1 right here, right? If this, or VDD, if I have VDD and VDD here, and then here's my gate, here's my source, and VSG, right? My VSG plus, minus, or minus, right? If my VSG is 0 for my PMOS, what does that happen? What happens? There's no voltage or gate source voltage. What does that mean for the PMOS? Come on, you're scaring me, y'all. If there's a 1 right here at the PMOS, it's an open, okay? I'm getting very scared, everyone, okay? I think I need to tell everyone this. So here's your NMOS, right? If I set this to 1, right? Set to 1, right? Then the NMOS just turns into a short. Right? Everyone understand that? And then let me just grab another marker because I love colors. Okay. And then when I set it to 0, right? It just turns into an open circuit. Okay? Everyone understanding that for the NMOS? Cool? And then for PMOS. Okay, right? Looks like this little bad dude. There you go, right? So for the NMOS, 1 makes it a short, 0 makes it an open, right? What does that mean for the PMOS? Everything's kind of upside down, right? So if I were to set a 1, right, it's going to be an open, right? Right? 1 volt at the gate. VGS, and then VS, and then if I were to put a 0, 0, right, 1 volt or something like that, VSG. Wait, open and short. Is everyone understanding what I'm trying to do right here? So for the PMOS, if there's a 1, it's an open. If there's a 0, it's a short. And then for the NMOS, I think NMOS is easier, okay? Because I think 1, boom, it's on, right? NMOS, it's on if it's 1. PMOS doesn't like 1s. They like 0s, okay? So don't forget that. So if I were to put, okay, let me just make a trivial question. Here's my output. If I put a 0 right here, right, what happens to this PMOS? It's a short, right? And it shorts to VDD. This output gets shorted, right? So the output is a 1, right? Make sense? Same thing with B, right? A or B, right? if one of them goes to ground, then the output gets shorted to ground or to VDD. Right? Make sense? Everyone see what's going on? So if I made B, right, or A and B, right? If I made B a 1, right? This turns this NMOS on, right? I'm going to grab an orange marker because this is very important. Okay, if I put a 1 right here, right? This is on, right? It's a short. Cool? Everyone understand that? But if there's a 1 right here, right? What happens to this PMOS? It's an open, right? So what does that mean about this PMOS? It's super high impedance, it's an open, doesn't do anything, right? But this does. However, depending on the state of this, we don't know what the output's going to be, right? Because this could be a 0, right? And it's off, so that means if this is a 0, that means this is 0, that means that's, boom, it's automatically shorted, right? So if I put a 1 right here, right? What happens to this guy? Also on, right? So boom, we have a short, and then what happens to this guy if there's a 1 right there? It's off, right? So we need A and B to make the output go to ground. A and B, they're both 1s, but the output is 0. What is that? NAND, right? Easy. The same thing can be thought about with the NOR circuit. Just flip the thing upside down so the NMOSs are in parallel. Okay, let me one more thing. Let me see. I'll do it right here. Watch how I draw my ugly transistors. Yeah, ugly transistors. I can't draw transistors. It's okay. Okay. This is in parallel, right? These circuits are in parallel right here. And then these guys right here are in series. Everyone see that? Parallel circuits are great because it's like A or B or C or D or ... right? When you see circuits in parallel, they're easy to short things. It's so easy to short things to like VDD. But with series circuits, right? You have to have A and B and C and to make the output force to ground or force to 0 or 1. Okay, so this can be flipped, this can up and down. NMOSs are at the bottom, PMOSs are on the top. Everyone understand what's going on? So you can research that on your own, okay? Anyways, I don't want to talk too deeply about that. But yeah, this is the assignment I want to publish for you guys. I think this is really fun. But yeah, that's the NAND symbol. Everyone remember this stuff? 220, or not 220, CP 200, 100. I go over this. Let me show you what I did. Really simple topology, okay? And then, oh yeah, for this one, I used 160 nanometers for the width of the PMOS. You want to know why? Because Lab 4, right? We saw that we got like the 20 and the 20 current for the NMOS and the PMOS, right? Remember that? The current meters? So I was like, I like this 160. I kind of want to keep things consistent. Like, oh, I want the same currents because I couldn't put the small value, and that's fine. But what's his name? I rather think like things match, and I think from Lab 4 we experimented with that number. So I want everyone to try to use that. Okay. Yeah. And then oh yeah, there's something you probably noticed. There's VDD right there, or DVDD. What does that mean? Digital VDD. And then there's a thing called DVSS for digital VSS. So I want something to I want you guys to learn this about me. I did some cool work as an analog layout engineer. Is great, but I also have to investigate digital. I had this great mentor. You probably don't know him, Leo. So, but yeah, I had the experience, and this is during my internship at Freedom Photonics at Santa Barbara. So. Something that I've learned is that digital logics, and you'll see this too, and I think they call it like digital noise. They slam up and down, right? They're just zeros and ones, just like hitting the floor and hitting the ceiling, right? Does that make sense with everybody? So they're gonna generate like these slamming noises on the rails, correct? this noise can couple into the analog circuits. So what I've noticed, my mentor told me, is keep the digital power systems and the analog ones like as far away as possible, and then on different VDD rails. Okay. But yeah, I think was it Dr. Harris? I had a CP professor. They were like, yeah, digital noise, and I'm like, what's digital noise? And no, digital noise is the noise from slamming up and down. Because let's say you have an unstable NAND gate that's like slamming up and down here. There's another circuit here that can feel that ring. It's like someone, like, I don't know, shouting at the end of the hallway, like, or hitting the floor. You'll hear it. It's like, I hear something, but it's not near you. But so point is, there's digital noise. Any questions about that? Anyways, and then I tell you guys how to do this, the symbol, not too hard. And then I said, okay, the symbol's kind of ugly, so we're gonna use the arc. And I tell you how to do it because I don't want people complaining on how to not do the symbol. Okay. Okay, and then look. Cute, right? Not that bad. Then you're gonna build a test bench for me. Okay, simple test bench. And then I gave you guys parameters. So, because I'm going to have someone complain about this. I followed your assignment 1-to-1 and it didn't work. I'm like, well, I assume you've already done the previous 3 labs, or 4 labs. So I'm hoping this shouldn't be too trivial, right? Okay, because if someone complains about this, I think that's where I'm going to be like, well, I'm going to make this class harder. Anyways. Oh, yeah, I simulated it. Look at this. And you're going to see the same thing too. It's really, really cool. A, B, out, right? And then you can use a strip function, okay? Or not strip function. Move to a new strip window. 0, 0, 1, right? 1, 1, 0. 0, 1, 1, 1, 0, 1, 0, 0, 1. Right? Pretty cool. And dot, dot, dot. And then I was going to talk about this, but this is actually a very important digital question. It's basically what happens when things like 2 gates change at the same time. And it's like this weird like crossover thing. And I know a lot of engineers get picky. And basically, I think that the meta is like, oh, just make it delayed by just a little bit so it doesn't like create, because this right here creates a lot of it's like a little power dissipation. But anyways, it can affect your output, okay? These inputs can affect it. So that's something I'll tell you about. But don't worry about it. That's a class for a different day. But yeah, I made this little truth table. Looks cute. Yeah. And then don't forget to save your state, okay? And then here's how you lay it out. Pretty scary, right? Not too scary, honestly. Just put the pieces in there. And then I give you guys the parameters. Please, no one complain in this class that this class is hard, okay? Unless I'll say you're lazy, okay? I do the rail system again. Let's see, rail system, right? The sub right here is going to be DVSS and DVDD, right? And then you see how big these are compared to the schematics themselves. Well, you got to think about it, but this is going to be powering like, I don't know, thousands of other transistors. So this is going to go a long way around the rails, all right? And then here's a simple layout, okay, pretty chill. And then, oh yeah, when you're doing layout design, you can also run Pegasus at the same time as you're designing things. So if you don't memorize the rules, that's okay. I don't remember them. So you can keep this open. Just press this rerun button as many times as you can until you like fix all your problems, okay? So yeah. And then, oh yeah, there's a new tool I want to show you guys. It's called P for path. You can create these little snakes right here. And by default, I think it's 80 nanometers. So I made this 160 nanometers. 160? Yeah, 160 nanometers to like make this path on level 2, metal 2, right? Because you see there's going to be crossover, right? Here's my, I'll show you. Or maybe I'll show you on layout. But anyways, a NAND gate. Pretty cute, right? And then, let me show you my proof. DRC, what time was this? 1 in the morning. Running my LVS at 1:06 in the morning. It took me 3 minutes because I had a weird LVS error. I tried to fix them for you, okay? So just copy paste. Did you learn things? Yes, no, maybe. That's on you, okay? 4-channel NAND. Okay, I really don't like pointing and clicking, by the way. This is a weird way of teaching. To make it a 4 channel, all you do, well, create a new schematic, right? 4 channel, 8 channel, 16 channel, right? And all you're gonna do is just add this little array index, okay? So all you do is just queue this part right here and just do this. So the caret bracket or the brackets or some, not brackets, they're called some arrow brackets. 1 to 4, okay? So that creates 4 devices, all right? And then you use the wide wire, and then boom, you can do something like that. Cool, right? The big fat wires. And then I'll show you how to probe from it. And then you can do the same thing with the pins, right? Same thing with what's his name? Quartus does this, right? You have to like make these bus systems and to like pull individual wires. You need to like be like, oh, this is wire 1, wire 2, wire 3 with the triangles, right? Or the whatever these called, carrots, whatever. Create the symbol, right? Now we have a symbol, right, that has 4 of these NAND gates all in, right? Not too bad. And then that's where I kind of end up, okay? But anyway, these bus systems are really, really chill. It makes these fat layouts, or not layouts, the layout's going to be a little It'll make these fat schematics squish down to one little one. And it's really, really cool. And the way to access this, and maybe I'll demonstrate it. Should I? Yeah, I think I will. Okay? Because this is what I want you doing for your final assignment, okay? And then there's a final project I want to talk about too. Yeah, I think I'll work on this on the tutorial. Let me see. So, yeah, this is my tutorial library, if anyone was wondering. My NAND gate, channel 4. Did I build the simulation? Not yet. Let me show you. Okay. Cool. So the easiest way to access this, well, first off, I'm going to do the following. A 1 to 4, right? And I'm going to put this label right here, right? Right? And then I'm going to do B 1 to 4. See, this is why I wanted to finish it, but I was like, I think I'd rather sleep. And then I'm going to do D VDD 1 to 4, okay? Right? And then DVSS 1 to 4. And you can get some cool DVSS. Actually, no, because this is my test circuit. So I'm going to do the following. And I haven't tried this yet, but let's see if it works. Analog lib. Everyone should be using this, okay? GND. If you use basic GND, I've noticed there's some weird glitches, and I think you and I, Colin, we've messed with some things with the ground. It was ugly. Anyways, let me just do this. I hope this works. If it doesn't work, I'll see what happens. Shift W for bigger wire. Boom, like that. I think this should work. If it doesn't work, I'm gonna get angry. Anyways, I think it might get angry. I think it might. I'm getting some type of PTSD from that. Anyways, L for out. 1 2 4. Boom. Okay, and then I'm gonna instantiate VDC. Okay, because I'm just gonna do a simple voltage. 1.1. Okay. So here's my, what's his name? 1 2 3 4. Okay, this is gonna be painful. Okay, because I'm gonna be doing this for your assignment. I don't think I'm gonna make you guys do this. I think I'm gonna just make you guys do the 2-channel version, because that's gonna be. You let me know. You guys want to do 1 channel or 2 channel? You let me know. Anyways, I'm gonna do an individual wire right here. Okay. Then I'm gonna copy this right there. Boom. So this is my 1, and then I'll show you what I'm trying to do. A1. Okay. Do I want to do that? Yeah, A1. No. Do it right here. My OCD is kicking in. A1. There we go. Boom. And this is how you access things. Like that. Okay? Anyways. and then I'm gonna copy paste. So please, if you're great at copy pasting, I encourage it. Like just find the easiest way to make it less painful. All right. I actually applaud if very practical copy paste. So if you're the king of copy paste, I know who you are. Or actually, I don't. So watch this. Watch this. Copy, paste. Oh, whoop. M for move. You guys see what I'm doing? I want you guys to have fun. Cadence could be super, super fun. And then watch this copy paste. Copy. Ah. Anyways, I'm gonna move this. Okay. Maybe I should have done this. Delete. There we go. Delete. You guys see my copy paste method? What am I gonna do after this? You guys like that? And then the voltage sources are upside down. It's fine, or not upside down. It's 4, 5. Whatever. So I'm gonna do the following. That's 1. This is 2. Okay. I'm just showing you what you're gonna do for your homework. Okay. Okay. I'm not going over assignment 4 because I already went deep into that one the last time. Okay. So watch that other video. What the heck? 1, 2, 3. 3. Okay. And then 4. Okay. Is that cool with everybody? And then what am I going to do here? I'm going to move this right here. Okay. I'm going to press C. Boom. You like that? And this is for my B. Okay. B. I press Q, and then I press the left arrow, I press the delete key, and then I press B. Boom, easy. And then B. You guys like these classes that I'm showing you? Is this worthwhile? Worth coming into my 1-hour class? I feel really bad because I know I have another class at 10 o'clock, and that's why I'm starting final projects for them, because the next 2 weeks I want to focus on you guys, okay? Finishing your final projects, okay? So I'm going to tell my other TA, the other Leo, to take care of them because I want to put more effort on you guys, okay? So the next 2 weeks I'm going to use the whole 2 hours and 30 minutes because I want to do some cool stuff, all right? Anyways, you guys see that? Pretty cool. So what I'm going to do here, you see 1, 1, 2, 2, 3, 3. I'm going to do, okay, what am I going to do here? I'm going to be lazy. Do 0 volts, right? I'm going to do, this is 0, 0, right? I just thought of something funny. Do I want you doing this? I don't know. Okay, maybe do this for me. Okay, this is gonna be cute. Okay, let's do A1, A1 like that. Okay. Ah man, this is gonna be a lot to copy paste. B1. Okay. And then you know what? I'm the true king of copy paste. A2. I'm gonna copy paste this. You see what I'm doing right there? Right, Dave? Watch this. A3. A4. Cool, right? And then I can go here. This is B1. This is B2. Does anyone know what I'm trying to do? B3. We're setting these variables up for our simulator. And then that's where the true power of the simulator comes in. So, yeah, if you want to do this is really cool. I like it. Anyways. Okay, this one might be the painful part. Actually, not too painful. Let me just copy paste this. Copy, paste, boom. And then, because I think this is going to generate me an error. I don't like this. I think this is going to generate me an error. Because what I'm saying is if I do the following, can everyone agree that this wire is called DVDD 1 to 4? And I routed that to here. All 4 channels are going here. That should work. This one here, I didn't label anything. I didn't label here, here. So I hope this is all connected to ground. I really do. If it's not, I'll get angry. Anyways, I won't get angry. Basic, No con. No con's your best friend, okay? Yeah, move this guy down a little bit. Shift W for big output. This should work. If it doesn't, I'll be whatever. It didn't work. Let's see. Errors exist. Okay to save? Yeah, sure. So it liked this. It didn't like that. Let me see. Why did it cry at me? Four bits can't connect to V10. Oh, are you kidding me? Okay, I knew it. I knew it was gonna happen. So it's saying you have a power source, and it's like you need 4 of them, and I'm like, what the heck? So do this. 1, 2, 4. Boom. Okay. 4 power supplies going to 4 wires, and this right here do the following. 1, 2, 4. There you go. That should work. And if you're getting annoyed by that, just cue this. Press both so you can see this label right there. Boom, you see that name? Like that. Cute. Check and save. Yay, liked it. Woo! I know my cadence. Tutorial. Yep. We did it. Launch the ADEL. This is going to be painful, okay? Not too painful. I'll show you guys. Transient. Let's do one micro. Okay, who wants to do conservative? Nah, let's do liberal. I'm feeling liberal today. Anyways, outputs. No, variable, sorry. What am I gonna do? A_1, 0. And I'm press add. A2, and then here's my copy paste king. 0, 0, A3. A 1, A4. I hope you guys are seeing how David thinks. Okay, so I'm gonna do the following. Maybe I should have done the following. It's okay. B1. This is gonna be 0. Add. B2. B2. Copy paste. Boom. 1. B3 is going to be 0. Okay, add, and this is B4. It's going to be 1. Everyone understanding what I'm trying to do? So basically, A1 and B1 are going to be 0, 0. A2 and B2 is going to be 0, 1. So I'm doing 0, 0, 1, 0, 1, 1, 0, 1, 1. All right? And you can, it's really, really cool. So I hope this works. Oh, yeah. Oh, shoes. Let's see if this works. Outputs to be plotted. Select on design. Let's see if this works. Ooh. Yeah, select them all. Yes. I love it. Guys, I love Cadence when it works. Oh, cute. I like that. Anyways. Oh, yeah. Turn off the magic pencil by pressing. Actually, do we turn off the magic pencil? No, we need to see this. Yeah, sure. Let's just select them all. Select that. Include as a bundle. That's what it was doing. Okay, cool. Okay. After that, we have the magic pencil on. Press escape. Boom. Okay. Just be very, very careful. Oh, whoops. Don't forget to set this voltage right here to 1.1 volt. Okay. Because that's our power supply. Any questions? Check and save. Let's run it. Let's run it. Come on, baby. What the haze? Oh, sorry. Let's see. Oh gosh, this is gonna be painful. Let me see. How do I move to new strip? Okay, this is B1. Move this one to this strip right here. And then where's my output? Right here. Out. Okay. So it's 0, 0, right? For one A and B, right? So here's B1. That's B. Here's A. It doesn't want me to highlight it. But you see this right here, output? Boom. 0, 0. A and B are 0, right? And then our output is 1, right? So now I'm going to do something painful, okay? Maybe you can find a better way to display this, but move to new sub window. Yeah, I like this. Okay, maybe let's do that. Okay, A2. Where's B2? Can I do this? I can. Great. Okay, do this. Everyone do this for me. Okay. So look at that. This is cool. Okay. Is that what I did? Let me see my ADE. Hold up. Something's funny. Ah, that's so cute. I like that. Okay. Anyways. Oh gosh, I love Cadence when it works. Oh, oops. Move to new sub window. Oh, okay. B3, A3, okay, and out 3. Boom. Cool. And then A4, I'm going to move this to new sub window. Okay, B4 is going to go over here. And now it's going to go, ooh, I see something funny. It's okay. There you go. Guys, like what I did? So this is my 0, 0, 0 case, or 0, 0, 1 case, right? See how my A's and B's are at 0, and here's my 1, right? Here's my 2. This is A is 0, and B is 1. What's the output? A is, okay. Okay, because if 1, okay, it should be 1. It should be 1. Sorry. Okay. This is the case right here. If A is 1, B is 1, out is 0. Okay. I'm blanking out. I was thinking AND gate for a second. Is that cool? And that's your assignment. Not that bad. And then if you don't want to, I think it saves markers too. You can do the fall. Did you know why I was chuckling at myself? Did you see that here? I didn't set B as 1.1 and I set it as 1, right? But for some reason it still worked. And that's okay. Not gonna lie, discrete logic is really, really chill. Basically, if it goes over that threshold, it's a 1 or a 0, right? But see, that's why I think we were blessed with some really nice transistors. But anyways, this is a really cool plot. Does everyone understand what's going on here? You're gonna label this and tell me like, wow, David. If you don't want to do what I did here, you can have individual windows or make it cleaner on your lab reports. Okay, so that's to demonstrate 4-channel busing. Cool. And look at that. You can do cool simulations from that. Cool. Or better yet, okay, let me show you what I was trying to do here. If I go here, let's just say I don't want 0, 0, right? I want to do 1 and, 1.1, or yeah, let's just do 1, 1, whatever, okay? For my A's and B's, right? Let's keep this to 0. A1 and B1, I'm going to make them 1, 1, okay? 1. All right? When I press the play button, I don't have to check and save. It's already done. Oh, let's hear the magic numbers. I reset, whatever. Dang it. A, that's A. B, you know what? I'm going to show you. Move to new window. Yay. Okay. And then let me see if it let me do this. Come on. Transient. Oh. Okay. Move to. I want to move it to here. Did it work? A, B. Move to new window? No, I don't want that. A, B, and can I? No, it won't let me pop it out. That's dumb. Anyways, what's the output supposed to be when A and B are 1? 0, right? Any questions about that? Save your work. Session, save state. Save this as testing 4-channel NAND. Okay? And then you don't have to worry about it. You can just do all your digital logic right there. And then funny enough, that's where the test engineers start playing with the simulator, like just making sure it works. Okay? That's a really cool job. You get paid, I think, like $130K for that. Yeah, it feels great. Anyways, what's the final thing I want you to do? Ooh. Layout. Anyways, display. Everyone did my display tutorial, right? Just go to File, Browse, double click my display options, load from, boom. All right, no work. I want efficiency. All right, you see that right there? That's my NAND gate, right? You guys like what I did? It's pretty chill. This is my sub, and then oh yeah, I rotated my transistors. So you know how I had them all like flipped one way, but I flipped them the other because then I can do this cool waterfall trick. Like, oh, I can just pull it from here and boom, waterfall like that. And you see these bodies? I could just connect it like this. Cool. And then look at this waterfall from here to here. But if you wanted to investigate this, be my very guest, you can use 2-finger device to let you see how you can connect this and this all together into one You can make this really, really tiny if you wanted to, but for demonstration purposes, this is what I did, okay? And then here's the gate. I didn't use a gate default gate, so I made my own gate like this, the via, right? From metal 1 to poly, right? I showed you that in the tutorial. And then same thing here. I flipped the PMOSs, okay? You see the power supplies, and you see how this right here is connected to that. So that's what I did. Pretty chill, okay? And then guess what's up above here? DVD. All right, and then gate. This gate has to connect to this gate right here, so use a metal 1 wire. And then try not to use too many jumps, because more jumps means more vias to go through, and these vias are about like 10 ohms, so they're pretty they're okay. But anyways, so here I went to level 2, metal 2, right? And then I used the P tool. If I press P right here, I can, and then just like that, you see? P, and oh yeah, I can do this. Cool, right? Actually, I don't like that P. Boom. If I press click and double click, it establishes a line, okay? If I want to make it thick, I just press Q, go to proper connectivity, no, width. Just set it to like, I don't know. Actually, this is for a poly, but if I wanted to make it 9, I can. Sounds cool? Any questions about that? Oh, my whole design's gone. You. All right. I'm glad you guys are enjoying this, okay? What am I going to do for 4-channel? I'm going to copy this right here. But let me see. There's an error here. You see my error? This black space. But what's in this black space? What do I have? What? Something's in here. And I think I know what it is. I think it's my sub. I think I need to move it a little bit to the right, because this sub box is pushing this way. I don't like that. Copy, right? And then let me see if I can do a mosaic copy, because this one, this version of Cadence is weird. You used to press the copy tool. Let me see. Create, edit, advance. Can I do mosaic? Copy. I want to do yank. What's yank do? Chop, merge, paste, convert. Convert. Nah, I don't want to do that. That's too hard. No more thinking. Copy, paste. Because there's a way where you can just copy, paste things, and you can do the following. You see that right there? Boom, 2 channels, right? What am I going to do? Copy, paste. Right here. And then go down here. 4-channel NAND. All right. What am I going to do next? DVDD. I I wonder if this is going to work. I hope it does. If it doesn't, I'll see what happens. DVDD is an input-output on metal 1. Okay, so I'm going to do the following. Right there. I'll stamp that right there. Cool. DVSS is going to be an input-output on metal 1. Right there. And I'll stamp that right there. Close enough. Sub is an input-output. Yeah, I think it was my sub pin that was doing something funky. There we go. So what are my other pins? Okay, this is where it gets annoying, but I'll show you what I'm gonna do. Okay. So if I do A, right? This is gonna be A channel 1. Okay. It's gonna be an input. Okay. On metal 1. Okay. Boom. I'm going to click right here on this little star. And that's my channel 1. Put this to 0.1. Cool. That's my channel 1, right? I'm going to be lazy. Boom. I'm going to cue this right here. I'm going to call this one channel B2. Let me see if this works. Yeah, it didn't work. Okay, I think I have to make them unique. You let me know. B. Oh, that means it might not work. Oh, God. I hope it doesn't. B channel 2 or B, yeah, B1. B 0.1. Okay. Oh, yeah, same thing. 0.11. All right, cool. And what I was trying to do, let me see if this works. If it doesn't work, error. Anyways, this is output on an. The out is going to be an output on metal 1. And I'll do the following, boom, boom, and click right there. Q, boom, 0.1. Cool. And this, let me see if this works, because I want to be the king of copy paste. Does this work? Yes, it do. So then let me do the following. Let me go here, Q this. Did it make it unique? I hope it did. If it didn't, I'll be correct. Okay, it did make it unique. Great. Okay, cue this and just turn this to 2. Okay. Turn this one to 2. And then turn this one to... You guys like copy pasting? Yep, I do too. 2. Boom. Guess what I'm going to do now? I press on this star right here. You see the star that I've been looking at? That's been my reference, okay? If you have a nice reference, everything should be happy. Okay. Go here. Boom. I'm going to cue this one right here. Cue A3. Was this layout hard? That's why I think, I don't know. I'll talk to you guys in a bit. I don't think this assignment was hard. That's why I quickly developed it really quickly. So, what's his name? The one that I have right here. It's just digital logic. Have fun. 4. Because I want to end off on something. I need it's like a disclaimer because I don't want people doing it. Okay. Boom. Everything's good? I think we're ready. I hope this works. I haven't tested it, but if it doesn't, anyways. Run your Pegasus, my DRC runs, rules, here, boom, let it load, and submit, yes. Not too bad, right? Let's see if I'm a rule breaker. Oh, let's see. Yep, we're good. Clean DRC, right? So let me go Pegasus, LVS. This is where problems are gonna happen. I hope we did it right. My heart's racing, y'all. This is like the big cheese. Like, you gotta make sure everything work. Input geometry and text, submit, and boom. Let's pull out our runner. Okay. All right. Moment of truth, everybody. And then that's the end of your assignment. Easy. We just did it in like an hour. Well, I did all the hard work for you guys, but you'll tell me how it works. All right. Where's my LVS? Here, it's right here. Let's see. Damn. Mismatch. All right. Let's see what happened. It says sub. Ah ha 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 ha. You know what's going on? It wants this. 1 to 4. Cannot change different number of bits. Schematic. Because DVD here works. That's what I want it to be. Let me see if I can do the following. I'm going to delete this. I'm going to press P. No, Control P. This is going to be DVD from 1 to 4. That worked. Great. Okay. It didn't like it when... What the heck? Oh, what happened? Oh, that's pretty sick. Oh wow, that's kind of cracked. Gee. This is cool. 4 right there. Whatever. This is ugly. Oh god. Do you guys like this? Is this entertaining? Aren't thou entertained? DVSS. See, look what it did. So if I press hide, right? I did that array. Let me just do it right here. Yeah, I see. I have that 1 to 4, but it didn't like make it like 1 pin. It popped out 4 others. I'm just gonna leave it like that. Hope your OCD or OCPD, like I don't know, doesn't flare up like how it did for me. There you go. Oh, delete this. P. There we go. Boom. Anyways, go home. Save. Pegasus. Oh wait, don't do that. Do this. Rerun. Not that bad of an assignment, right? Cool. Did Ming do this for you guys last semester? Dang, you guys really wish I was there, huh? I'll be doing 421 lab. I'll look for you. What? Yeah, 421. Lab, yes. Different labels for nets, comparison shorts. I'm getting 20 different problems. Let me see. Multiple labels. Oh, don't tell me. Oh, no. I made them unique power supplies. It should be 1 power supply. So basically it's saying it's 4-channel, but I treat it as a true 4-channel, and they all had their DVD1, DVD. So basically DVD1 could be 5 volts, DVD2 can be 10 volts. So you know what that means? Got to go back to the original schematic. Let me see. Come on. Did Cadence freeze on me? Nope, didn't. This is 1 shared DVD. Okay. Okay. Ba-ba-bum. And I'm going to do the following. I'm going to press one wire like that, okay? And then, because I hope it does this. DVDD 1, 2, 4, right? This is this label right here, right? And then I'm going to do the fall, because I don't know. I hope this works. P for DVDD. Oh. Wait, what? P? DVDD. Cannot create DVDD because there's a name conflict. So X and X01 cannot coexist with the following nets. You know what? I'm just gonna be angry at it. Fine. You want to be special, huh? DVDD. What do you mean? Save. Oh. Are you kidding me? You know what? I think it's is it really barking at this? Please don't do this to me. Bark at you. Okay. One power supply. One sub. One DVSS. Share. Okay. Check and save. Whatever. Darn. Okay. P. DVDD. A name conflict. What do you mean? This is gonna be. This is unique. This is unique. This has to be shared. Is there a residue somewhere? I'm gonna call it DVDD2. There we go. I hope you like them apples. There we go. Okay. Let's see if it's gonna do the same thing here. DVSS. Yeah. Don't do what I just did to whatever. I really was hoping for that. Sub 2. Whatever. Save, but don't check and save. Because it's gonna bark at you. There we go. I'm gonna call this one DVDD2. 2. And this might be a good lesson for everybody here. Is you know how we have substrate, right? And that can coexist everywhere. It's okay to call a different circuit like sub 2, sub dirty sub, or I don't know, sub. In the end, it's the top hierarchy that matters, and that's where you can do like the master name, okay? So yeah, even though this is gonna be unique, it's okay, whatever. Check and save, yay. Check and save, yay. So 1, 1, 1, okay? I'm getting afraid, everybody. Anyways, I hope I'm getting scared. Sim my NAND gate. I hope this still works. You see, this is why I told you guys to save that stuff. Okay. Oh god, I really hope it doesn't choke here. I'm gonna be so angry. DVDD. Okay, it did like that. Okay, cool. DVDD. Right? And then all this is going to be wires. No more complaints. Everyone like that? Yep, it liked it. Launch the ADEL session because I'm lazy. Load state. No, I have to stop calling myself lazy. I'm very efficient. Time is money. Still worked. Oh, wait, did it work? Let's run it again. Was Spectre ended with a Check and save. Fatal error. What the heck? I did check and save stuff. Oh. It didn't like that there's 4 power supplies. There's 1 ground here. That's good. Yay, it worked. Did it work? Let me just... Yes, it worked. Oh, God, I'm dying, everybody. Anyways. Come on, everybody, because this is the big cheese right here. Delete all this. Boom. Delete. Delete. All this stuff. P. Control P. DVDD. Metal 1. Yay. Clean. Control P. DVSS. Yay. Control P. Subscribe. No, wait. Oops. Someone catch my fatal error. It's supposed to be sub_2. Q. This is supposed to be DVSS_2, right? Because that's what I did in the schematic and the symbol. Boom, boom, save. Pegasus. Rerun. Let's go. If it LVS's, let's have a good day, everybody. Oh, God. Come on, baby. Bingo! That's the end of Lab 5, and that's the end of the semester right there. So you guys like that? Was that cool? So now you guys are ready. I feel very confident that you guys can build some cool circuits. So now we can talk a little bit about the final project. See, gotta love all the green boxes, okay? That's what I want to see on your reports. I want to see that funny enough, this will tell you if it didn't finish. It'll be like Pegasus died or something like that. So I need to see this. I just want to see what time you guys are waking up. Anyways, but no, this is legitimate. I need to see this one. And this right here is money. Okay, I need to see this. Okay, and that's ready for fabrication. Cool. Anyways, for your final projects, oops, I clicked the wrong button there. Do you really wish to quit? Yeah, sure. Quit everything. So I have the CMOS textbook, and I think, let me see, project matures. Oh yeah, that's Dr. Baker's hands. You see, oh yeah, that's a wafer. You guys know what wafers are? These big circles right there. So yeah, that's where your chips are gonna get printed. If I want to get them printed, let me see. Is there a project here? Because he has a. Oh, there you go. Possible student projects. This is what I've thrown at you guys. You see. Quad to input mux. You guys know what that is? Multiplexers, right? Just changing channels, right? Clock doubling circuit using exclusive OR. So I had someone email me saying, hey, can I use an XOR as my final project? You can build the XOR, but it sounds too simple. I want to do some really cool projects, okay? Like the clock doubling circuit, so frequency multiplication, right? That sounds cool. So I want you guys doing that, okay? That's also the reason why I did Lab 5, the NAND gate, because if someone comes to me saying, can I do a NAND gate for none? You can build it, but I need you to do it with something else, okay? I want you doing some really valuable stuff because this is going to be to interviews. Basically, my name's going to be stamped on to your guys' course. You're going to go to interview at Apple, Intel, Micron, and they're going to be like, who was your instructor? David Santiago. And they'll be like, oh, they're doing good things. Yeah, keep hiring from UNLV. Or if you embarrass me, they'll be like, they're not teaching anything. Okay, I'm teaching the tools, and I want to make it look like we're legitimate. We have some great resources, and this is the experience I want to pass down from me to you, okay? And funny enough, a lot of these projects are really, really cool. Schmidt triggers. I think you guys built a Schmidt trigger. Try something different. So I'm gonna try something cool because I want everyone to also just test their circuit, LVS it, DRC it, make sure it's fun. All right. D flip flops, D flip flops, SR flip flops, buffer with tri-state. Oh, these are good. 1 of 6 decoder, shift registers. This is all just CPE stuff. Current star VCO. Ooh, I like that one. That one's cool. What do you call it? PE gate to implement this mathematics. Okay. Buffer for driving up 20 picofarad load with minimum delay. So if you want to build a buffer and show me that you can do this, sounds cool. Advanced projects. Ooh, okay, let's get to this one. 64-bit static RAM. I don't want you. That's a little too advanced. But point is, that was a final project for 420 or 421 years ago. You see how much things have changed? Charge pumps. Yeah. DRAM. Ooh, scary. Ooh, digital PLLs. I like this. Oh, this is money, y'all. If you put this on your resume and say it works, this right here gets this. I think these two right here will get you jobs. Not going to actually. All this right here is going to get you jobs. I'm not saying that these aren't bad. They're really simple. Okay, I'm giving you that option. If you want to do this for your just get in, get out, go home. That's be my guess. Final announcement. Yes, design the project for me. Okay, design it for me. Design it for your interviewers. You can submit the same project for Dr. Mingzu. Okay, so I want to show him what I've done. Okay, show him the best that Dave showed you. Okay, so he'll be like grading and he'll be like, dang, David's students did good. All right, everybody. So I want everyone to just talk to me. Let me pre-approve your projects, but don't come to me saying, "Can I just do like a It sounds great, like 100-bit NAND, well, or invert, or like do something practical, okay? Something that will make sense. All right. I'll send you guys this picture today, hopefully soon. What other projects? Is there other projects here? Possible student projects. Project. But yeah, there's a lot of things in here. Let me just go to the top of the page, okay? Oh, 9:52. I still have a lot of time because I thought I was running out of time. I saw 9:57, so I was like rushing a little bit there. Let me see. CMOS EDU. Oh, he doesn't. Okay, let me see. Let's just talk about things. He talks about a lot of things here. Personally, I would have used this book for 420 because we would have honestly talked about this chapter right here. MOSFET operation. This is really, really good. If you haven't gotten the book, this is a suggested read I would buy. CMOS chapter 4, or not CMOS chapter 4, CMOS EDU. CMOS EDU. Click on this link. Click on this link, or not the link. Errata. Let me see. Can I buy this book? Come on, Dr. Baker. How can I buy this book from your website and you can get your commissions? Oh yeah, this is also a really good book. I really love this book here too. There's a lot of cool projects from this. If you want to use this book too, be my very guest. But there might be a more advanced. So if you're a signals and systems person, if you want to investigate that, be my very guest. Let me see. Courses for 721. Course lecture notes. Yeah, Schmidt trigger. You see, he has a lecture on Schmidt triggers, charge pumps, multi-vibrator circuits, VCOs, current star VCO, loop filters, XOR DPLLs, NAND, NOR, DRAM, SRAM. Big words, right? Oversampling. Cute. Delay locked loops. Gosh. If you want to pick a project from this class, be my very guest, okay? There's that. There's, let me see, 421. So you have a lot of resources out there, okay? I want you, okay. CMOS, is there any good ones? Don't build me an inverter, okay? I'll be embarrassed. Yeah, SRAM, DRAM. Maybe do a ring oscillator. Show me something cool. 1T, 1C, memory cell. Oh, yeah, you can do some cool memory circuits, okay? And I want you guys having some fun, all right? But anyways, were there any questions about how I did this assignment right here? And you guys saw that all that really cool layout, right? Everyone can build the following NAND gate. Easy. Assignment 5. And then final project. I'll publish that very soon. Or, yeah, final project, yes. All right. Have a good day, everybody.